Good afternoon, everyone. Today, we are going to discuss a fascinating innovation in the field of biotechnology, bioink, used for 3D printing human tissues and organs. Medical science has advanced rapidly in recent years, but organ transplantation still faces many challenges. Scientists around the world are now exploring new technologies that could transform the way organs are created and transplanted. One of the most promising technologies is 3D bioprinting where living cells are printed to create tissues. Innovations in biotechnology are also being encouraged in India through organizations like Kerala Startup Mission, which supports research and startups working on advanced healthcare technologies. Today, in this podcast, we will explain what bioink is, how 3D printing works, and how this technology could change the future of medicine. Now, Devika will say about the problems.
The problem, organ shortage. Before understanding this technology, it's important to know the problem it is tried to solve. Across the world, thousands of patients are waiting for organ transplants, such as kidneys, liver, and hearts. Unfortunately, there are not enough donors available. Many patients have to wait for years, and some sadly lose their lives before the suitable donor is found. Another challenge is organ rejection. Even when a transplant is successful, the patient's immune system may reject the donated organ because it recognizes it as a foreign object. It means patients must take medicines for the rest of their lives to prevent rejection. Because of these challenges, scientists are searching for new ways to create organs artificially. This is where 3D bioprinting technology becomes very important.
Now I invite Srinanda to say about 3D bioprinting.
3D bioprinting is a technology that works in a similar way to a normal 3D printer. In a normal 3D printer, materials like plastic or metal are printed layer by layer to create objects. But in 3D bioprinting, the printer uses living cells instead of plastic to create biological structures. The printer follows a digital design created by scientists and carefully places cells layer by layer to build tissue structures that resemble real human tissues. The process allows scientists to create tissues with specific shapes and structures. Researchers are already able to print simple tissues like skin and cartilage, and they are working towards printing more complex organs in the future.
Now I invite Blessy to say about the bioink.
The most important component of 3D bioprinting is bioink. Bioink is a special substance made from living cells combined with biomaterials such as proteins, hydrogels, and nutrients. These materials help keep the cells alive and allow them to grow and develop after printing. The bioink must have very special properties. It needs to be soft enough to pass through the printer nozzle, but strong enough to hold its shape once it is printed. Scientists spend a lot of time developing the right composition of bioink so that the printed tissues can function properly. Because bioink contains living cells, it behaves very differently from normal printing materials, which makes this technology both complex and exciting.
Now I invite Sabit to say the process behind 3D bioprinting.
The process of 3D bioprinting usually involves several steps. First, scientists collect living tissues from the patient's body. These cells could be stem cells or specialized cells, depending on the tissue that needs to be created. Next, the cells are mixed with biomaterials and nutrients to form the bioink. This mixture is then loaded into a bioprinter. The printer then prints the cells layer by layer according to a digital model. After printing, the tissue is placed in a special place where the cells continue to grow and develop. Over time, these cells interact with each other and form tissue structures that can function similarly to a neutral human tissues.
Now let's invite Sanam to say the benefits and the future possibilities of 3D bioprinting.
3D bioprinting has several potential benefits for the medical field. First, it could significantly reduce the shortage of donor organ. If organ can be printed in laboratories, patients may not have to wait for years for a donor. Second, if the printed organs are made using a patient's own cells, the chances of organ rejection will be much lower. This means patients may not need strong lifelong medication. Another benefit is that scientists can use printed tissues for drug testing and medical research. Instead of testing drugs on minimal researchers, could test them on printed human tissues. In the future, this technology may allow doctors to print customized organs specifically designed for each patient.
Conclusion: although scientists have not yet fully printed complex organs like the heart or liver for transplantation, research in this field is progressing quickly. Currently, researchers have successfully printed tissue such as skin, cartilage, and small tissue structures. As technology improves, printing full organs may become possible in the future. Innovations like bioink and 3D bioprinting show how science can provide solutions to some of the biggest medical challenges. To conclude, this technology has the potential to revolutionize healthcare by making organ transplants faster, safer, and more accessible for patients around the world. Thank you for listening to our podcast. We hope this discussion helped you understand the exciting possibilities of bioink and 3D printing. Thank you.